Alright. Yo, what up, everyone? Welcome back to my Twitch, Kick, Rumble, and YouTube channels. Make sure you guys subscribe and follow. Alright, let's get on with this. More news about the Steam hardware. This video is Gamer Nexus video, so make sure you guys subscribe and follow to Gamer Nexus. Let me switch scenes right here. Alright, hopefully you guys could see it better. I got rid of the stuff down below, that way you guys could view more of the video of whatever I'm watching on my screen. And let's get on with this video.
Valve announced the Steam Frame, Steam Machine, and Steam Controller yesterday. We covered all that in detail, but we have more. This video goes deeper on the engineering of the Steam Frame VR headset specifically. Normally, we don't record every minute of our time with the company, but Valve was cool with it, and we had two separate deep dive discussions with Valve's engineers about the Frame VR headset. We didn't want to just let that great, highly technical content go unseen. For example.
Yeah, so lasers are great because they're non-contact, and so you can capture the motion without interfering.
All of those vias are actually working as a thermal transfer through the PCB itself.
Best way we're able to get those fast transition times at the higher frame rates is through the warmth of the device.
So in this video, we'll talk with Valve's engineers about some of the acoustic considerations.
It has some amplification from its location, so it's, and then you take all that back into the software layer, and you see the sampling rate of the IME. It was a little complicated.
Some of the thermal solution design.
So when we told Michael that we wanted to flip the SoC to the opposite side, he immediately started thinking about those power management ICs. It was like, oh man, you're killing me. This is the worst thing ever.
And some of the PCB design and layout challenges.
There's a lot of impedance requirements. Okay. So everything wants to be really close to where it has to go. But you can't really concentrate all of that heat. So it was definitely a packaging exercise.
We're not going to heavily edit and produce this, so you're going to get basically the raw conversations that were just us talking, not intended for camera, but we captured it anyway just in case it was useful, and it was. Valve made sure to have engineers from basically every aspect of the hardware available, which is awesome, and so we were able to get pretty much all of our questions answered. These are fairly casual conversations with a lot of detail to learn about the relevant sciences and Valve's hardware engineering process. So let's get into it. Before that, this video is brought to you by Haven and their new BF360 flow case. The band using the management channels, rubber Haven
Output from this guy. And so we literally took the board, mounted it up to a water cooler, and then looked at actually the thermal performance of the heat going out of the backside of the board, as well as actually directly off the top of the SoC. So it's pop memory. So you essentially have the main SoC plus the memory stacked on top of it. That's actually going to impede the heat. Right?
Is it vertically stacked?
Yep.
On the silicon?
Exactly.
Okay.
Yep.
Yeah,
So
it's
just
a package on package. So the memory chip solders on top of the SoC.
Cool.
Exactly.
Cool.
Yeah. So essentially, you can think of it as two direct paths where heat could go, either through the pop memory up into a heatsink, or you could actually go straight through the board. Yeah. And if you think about it, like in the case of an SoC with a ton of vias, right? All of those vias are actually working as a thermal transfer through the PCB itself. So essentially what we did is we said, okay, let's just throw out this idea here. Maybe we can actually pull more heat out of the backside of the board.
Yeah.
So we moved a number of components around so that instead of there being a number of capacitors, inductors, all of those components, let's kind of shove them all to the side and then create these big pads that we could actually clamp an additional piece of metal to.
Right.
And then that would be where we'd actually connect
So
a second heat pipe to.
On the back side of the PCB, is it relatively bare there?
Well,
On the back.
so this
the
is
flip
actually
side?
the backside of the PCB, effectively, that you're looking at right there.
Yeah.
So we moved the SoC actually from this side here originally to the backside. And so that area normally is where you would have a bunch of components that are just, bypass capacitors, a bunch of components that would be critical to driving the SoC. But normally they're just kind of placed there. They're like, oh, here's a good location. And we said, we worked closely with Qualcomm and saying, hey, can we figure out how to kind of move things around a little bit, because we're really trying to push this thing super hard. So we created these keep out areas that allows us to have additional elements that clamp down, that actually couple super well to that heat pipe.
Is this a thermal putty under the
Yeah.
cold plate? Okay.
Yep.
And then I guess 8mm flat heat pipe? 6 or 8?
I don't know the exact
That sounds
dimension.
like a roughly correct number. I can check on that. For you.
Anything? Is it just a fin stack up here, or is there any
That is-
components?
No components up
Okay.
there. Just a fin bank that's been welded essentially to that to the heat pipe. there.
Okay, are you soldering to the heat pipe
Yep.
or welding to
Yep.
it?
Yep.
Okay.
It's directly connected
Cool.
there. Yeah.
Okay.
For the most part, on the aluminum side, the other heat pipe, there's a cutout that goes down and touches the SOC
Oh,
top,
okay.
and then that heat pipe is bonded to the
Got it.
To the mid wall.
midwall.
Yeah.
Yeah.
Cool. Very cool.
Yep.
Um,
Yeah, so basically, you can imagine a scenario of different kind of ways that people would connect the thermal solution
Right.
on these types of SOCs. One would be no thermal solution at all, and then maybe they would have a heat spreader, and then maybe they would have maybe a heat pipe that would actually go to some other place, whether it's a phone or
Right.
something like that. In this case, we're basically saying dual heat pipes. We're saying, a big fan that's going to be moving a ton of air. That fan can run. I could get you some more precise numbers or whatever, but it gets loud, right?
Right.
Like if you're running it
If
at
you
the
really run
maximum,
it, yeah.
we're going to have a sweet spot that's going to be you're going to be happy to be, running it as is. But if for power users that are like, I want to just max this thing out and see what it can do, that'll be an option.
the question I'm going to have at the end of this is how much
As long as it's not too annoying, because it's like right by your ears and the vibration and everything you hear. Like if the fan is spinning, I don't know if this has a fan. Probably not. This is the Quest 3. So if you hear a fan like right up here, you're gonna hear it. I wonder how they're gonna do it to make it so that it's not annoying, but you could try to get as much as you can out of that VR headset. I'm basically here trying to find out whether it's gonna be worth either ditching the Quest 3 or replacing it or getting it as well, if it's worth it, or should I just keep the Quest 3 for now and then wait for them to, I don't know, make a new version.
of the air flowing through other locations on the device is to cool sort of periphery components on the PCB. But the two considerations would be you're obviously limited on sort of total porous area you can even pull air through to begin with.
That's true. Yeah.
And so puncturing everywhere lets you pull more in just in total. But then, secondarily with the DEC OLED, and
I'm gonna put this at like 1.25 times because, yeah. Let's see, speed timer, playback speed. We put it at 1.5 times. Let's see how. Yeah, let's see how it is.
particular, I
Perfect.
remember talking about how the OLED had moved some components around to better guide air as it comes through the inlet across those components.
That's definitely a consideration.
Yes. So is there anything heat sensitive, particularly beyond the SoC?
Yeah, definitely. So there's a Wi-Fi chip. That's depending upon what kind of mode you're operating in, it's going to put off some power. There's also when you're looking at the power delivery network that actually goes, from the battery ultimately through the various regulators that are taking that battery voltage and dropping it down and delivering the power into the SoC, those are not 100% efficient. So some of the components that we're touching off right there are also the power management ICs that are, this is stuff that Michael spent inordinate amount of time
So is there anything?
trying to pull heat out of those as well.
I'm glad you mentioned because I wasn't sure if I should even bother asking or not, but VRM is often like, it's in a lot of devices it's almost a commodity, where the VRM is the voltage regulator is kind of like a given. It's not super interesting, but is there anything particularly special or that required more creative engineering, I guess, on the VRM side?
It was definitely a packaging challenge, I would say. It's a lot of power that we're able to generate, so trying to get everything tight. There's a lot of impedance requirements, so everything wants to be really close to where it has to go. But you can't really concentrate all of that heat, so it was definitely a packaging exercise, for sure.
So when we told Michael that we wanted to flip the SoC to the opposite side, he immediately started thinking about those power management ICs and was like, oh man, you're killing me, this is the worst thing ever.
All the rails that have to move. And
So it's pretty fine at 1.5 times. It's a little bit more, not too slow. Like if you're in there in person, but it's fast enough so that you could get through as much info as possible, and still be able to understand it. There's a lot of this shit, like the acronyms, abbreviations, whatever, that they use that I also do not know, and then like IC, like what is it? Internal component, or is it? I don't know what IC stands for. I'll look it up later, but I could get the gist of their conversation, and basically what if they're talking about a certain component, like, and they mention like heating and stuff, like obviously it has to do with heating and stuff. You could kind of piece the shit together. You guys are not trying to become like computer engineers like me, so a lot of this info might not be that important. Whatever I do understand, I'll try to like dumb it down to like my level or below. That way you guys and I could understand it. I talk to myself sometimes when I try to figure it out, so might as well say it out loud for my viewers.
Yeah, you killed my dog. You know, exactly.
So what is that? How does that? What does your job look like? I guess when you are trying to figure out how to meet the packaging or the density considerations. Are you in software just moving things to see what fits? You know, or are you running calculations?
There's definitely a little bit of that. There's a lot of simulation for sure, especially for impedance requirements. The temperature pieces are a little bit more challenging to simulate for some of that,
right?
Because it's only as good from a sim as the whole system, which is relatively difficult to simulate. But yeah, kind of all of the above.
Got it.
Yeah. So.
Hold on 1 second. Let me just double check that my microphone is turned on and not turned off, or else I'm speaking to myself. Okay, it's on. All right, there you go. Going back.
Along the way, what we did, you know, because we're just like, hey, you know, we're an engineering company, right? We're just like, this is the kind of stuff we really want to like nerd out on. Is like, we're like, how many temperature sensors can we add in there? You know, can we ship with those? You know, how many power measurements can we get in line? And the answer is we put a whole bunch of them in there. Michael could probably give you exact details, but the general idea is, you know, we're able to measure the power on these Qualcomm SoCs. You typically have, there's a series of temperature measurements that are in the SoC itself, a ton, and those are really accurate, and you basically need those for everything. And then there's also the ability to break out power rails that are dedicated to different CPU clusters as well as the GPU. So you can imagine you've got, you know, one CPU cluster that would be the cores 0 and 1, and then there's a different CPU cluster for cores 2, 3, and 4, and then a different one for 5, 6, and 7. And those 3 different cores have dedicated power rails. So we actually put inline power meters directly for each of those for the CPU, and then also the same thing for the GPU. And then I kept telling Michael, like, hey, how many more can we get in there? So we have a number of other ones as well that we've broken out. So we really have a pretty good map of the power flow in the device as far as like efficiency, you know, how much power is actually making it into each of the different CPU clusters. And so when we're playing a game or testing things out, we can say, okay, this game is CPU you know, intensive, this game is GPU intensive. Here's what the curve looks like when we're tweaking the GPU or CPU frequencies. Here's what it looks like from device to device. You know, so we're just getting tons and tons of data, and then we're also getting all the temperature data
on top of that.
Yeah. How many sensors would you say we have for the thermistors that we've placed externally? Not directly on the SoC itself.
I don't remember the exact number.
But like,
ballpark, it's like 10 thermistors.
A lot of you guys are gamers watching this shit, right? You guys understand what GPU and CPUs are? Graphics power unit and computational power unit? Or let me maybe I'm fucking this shit up too. So let's let's go to ChatGPT. Or I'm fucking learning about this shit too, but just to get like the list of components, what are the basic components? Hey, the German Shepherd playing with his bone. Hey, buddy! Basic components of a PC. A PC. And then, let's see. I see. See, this is why I'm saying there might be saying internal components, I'm pretty sure, but it could stand for something else. CPU, Central Processing Unit, is the main processor, handles all calculations and instructions. The GPU, Graphics Processing Unit, not Power Unit, renders graphics, can be integrated into a CPU or a separate dedicated card. motherboard. So they were talking about the PCB. Basically, it's I'll search it or whatever. It's basically a motherboard. The main circuit board all components plug into is this. Provides power delivery, expansion slots, and communication pathways. RAM, short term, is fast storage used for active tasking programs. Oh, excuse me again. Soda. Storage, SSD or HDD hard drives. Long-term storage for operating system, software, and files. PSU, power supply unit. That's why I keep on saying power. Converts AC wall power into usable DC power and PC components. The cooling system includes the CPU cooler, air, or liquid and case fans. It prevents overheating. The case, chassis, physical enclosure that holds all holds and protects all the hardware inside. Let's see, dedicated sound card only needed for advanced audio setups. Most motherboards include integrated audio network card, sometimes integrated into the motherboard, otherwise added through PCIe. Optical drives like the DVD, Blu-ray that they're not adding onto some of the consoles anymore. Less common today. Yeah, everything's digital. Expansion cards, capture cards, RAID cards, USB expansion cards, etc. Essential peripherals: a monitor, keyboard, mouse, operating system, software foundation like Windows, Linux, fuck Windows, get Linux, Mac OS. I'm dealing with it for now. Apple hardware only. I'm eventually gonna get rid of my Apple products right now, but I'll just explain to you why I have an iPhone. Because I told myself if they ever sort of catch up to like Samsung or Android with some of the basic crap that you really would miss in Android, once they kind of catch up, then I'll go over, especially the OLED and the let's see, above the 120 hertz display screen. Once they got that, that's why I got the iPhone 14 Pro Max. Also, because it became sort of around the same price. Like Apple used to be super expensive for some fucking reason. For the I don't know, it wasn't worth it back then, basically. So I got it. Especially I have T-Mobile, so I did the payment plans or whatever for it, and I ended up getting also like not a discount, but like one of these reward program, one of those fucking programs where I got something else out of it. Anyways, I got it through there, and then the cost of it was pretty much the same as the Samsung phones, or cheaper actually, because through me getting it through T-Mobile, it was actually pretty cheaper. So I'm like, I'm gonna upgrade. My last phone got cracked. Let's see, the phone before this one I had was the Z Flip 3. Yeah, it was a 3, and then before that was the Samsung Galaxy S10 Plus. The last one that had the little headphone jack. So I actually have both those devices, and I kept them because I'm gonna make a project out of them. Maybe after I fix it up, I could, I don't know, make it into a I don't know, a server scanner or whatever. I don't know, security. I'll use it for some shit. Whatever. I'm keeping those components so I could use it for something else. Anyways, let's get back to the video. Those are basic PC components. I'll keep ChatGPT open right now.
And probably like 30 die temperatures, scattered throughout, and
Cool.
a lot. So you can draw a pretty good map.
Is the fan basically
able to use all of that
Yeah,
data.
it's responding to those thermistors.
Yeah, so we have a totally custom fan curve. You know, one of the great things with the open source model, you know, this is running Linux, it's SteamOS. You know, we write all of the kernel drivers. You know, we're interacting with the folks upstream. We're benefiting from what we've learned on the Steam Deck as well as Steam Machine.
Also, I'm keeping that iPhone as long as possible. all the phones, it's unnecessary to upgrade after every year or 2 years, unless it's like really. It might be gimmicky, but like at least the flip, like it has an extra function. Uh, like yeah, you can make it smaller. It's actually pretty good. It's just the screen eventually, like you bend it, no matter what, it ends up breaking, and then it's hard to fix. So the I went back to the solid phone, like the solid-ish screen. Um, it lasts longer. You put a case on it, it'll last super long. And it still does everything you need it to. Plus, I rarely even use my cell phone, so I can't justify continuously buying the new shit over and over again. Like, besides for bragging or I don't know, keeping up with, I don't know, FAFO, FAFO, fear of fuck around and find out. No, it's not. It's not FAFO. It's fear of missing out. So FAMO, okay, that fear of missing out. And I like technology and shit, but I do miss Samsung phones. Although I also because I'm what's it called, investing in the stock market, S&P 500 and shit, even with my Roth IRA and yada yada, and also with my life insurance policy. Anyways, Samsung is international, and I'm not I'm not invested internationally yet. I'm mostly invested in stuff in the U.S. economy, U.S. markets, basically. Um, so that's another justification of keeping um, Apple products. Um, yeah, let's move on. What is that noise? There's a loud ass airplane outside.
So yeah, so we have algorithms that are running that are essentially reading all of those data points and saying, okay, which one is going to actually give us the best data for this type of a load? In other cases, we might say, we could have different.
That's what she said.
Profiles. We could have a variety of different things. So that's stuff we're actually working on right now.
Cool.
We've even been doing some airflow studies, flowing through the device. I'm not sure we want to show on camera exactly yet, but we do have some stuff that we can just show you to kind of give you an idea of the types of stuff that we've been doing. We have a video we can show you.
Smoke testing, what you mentioned earlier. Yeah, that's cool. Any other special challenges, things that you want to draw attention to? Things that you overcame that you want to point out?
Purina conducts. It's not that bad of a commercial. I'd rather have these kind of commercials than anything else. Although I'm not gonna fucking purchase any of that shit though, but yeah.
I mean, that one's probably like the most complicated. I think in any device that...
Who doesn't like seeing puppies?
Has this many things coming together. We've really had to optimize the data flow essentially from the cameras, from the displays, or going obviously to the displays, the wireless link, and really all of this is, there's a lot of demands on the memory, right? So you have, it's like I said, it's LPDDR5X, it's the 4266 as we were discussing, and so you really have to optimize all of that. So if we're going to be running the cameras at the same time we're running the GPU and also running the CPU as well as the displays, all of that puts a demand on the memory. So that's been a big thing where we've had to really do an awesome job there.
I guess you've kind of got almost two thresholds thermally. You have the threshold where the SoC and the other components cannot operate above a certain temperature, right? And then you have whatever the human, like the user's sensitivity is to the device on their face. So do you trip the SoC sensitivity threshold before the user threshold is a problem? Meaning,
that's an interesting question.
You get where I'm going with that?
Yeah. I would say that we're using these devices every day. We all are pushing the limits of these all the time. So.
What is an SoC sensor? SoC sensor refers to a sensor built into a system on chip. SoC, system on chip, is a single chip that combines both components, the CPU, GPU, memory, controls, radios, and various sensors into one integrated package. In short, SoC sensor is a hardware sensor integrated directly into a system on chip. Okay. What SoC sensors usually include, depending on the device, phones, tablets, embedded systems, laptops, and SoC may contain Temperature sensors monitors the chip's internal temperature to prevent overheating and managing throttling. Voltage sensors check power levels and protect against over voltage and under voltage. Current sensors monitor power draw of different parts of the SoC. Battery related SoC sensors on phone and tablets. These track battery state of charge. This is a different meaning where SoC refers to state of charge, not system on chip. Examples: battery percentage, temperature, health, charging rate. Accelerometer, gyroscope, magnetometer, or magnetometer. Common in mobile SoCs that integrate motion sensors. Two meanings of to be aware of. There are two different uses of SoC sensor depending on the context. So the one they're talking about is system on chip sensor. Sensor embedded on SoC, silicon, temperature, voltage, current, common in PCs, phones, Raspberry Pi, embedded boards, etc. And state of charge is obviously not what we're looking at or listening to.
It's hard to say where a particular user would be saying, okay, this is uncomfortable to wear, you know, if we were running it at the absolute max level. But we're doing a really good job of decoupling that thermal interface that's up here from the user.
Right.
So, and that's the type of stuff that, you know, if we were putting it on our head and saying, hey, this is uncomfortable, then that would definitely be totally unacceptable.
Right.
So, you know, that's the type of thing where, you know, we don't believe that that's going to be a common complaint from users because of the way that we're designing it.
Yeah.
But if you weren't controlling for that, for sure, that could be problematic.
Right.
So yeah, so we're definitely.
I mean, it's going to get warm just from putting your face in goggles, you know.
Totally.
And so that's kind of what I was curious about. Is
Right,
like,
yeah.
does the rest of the device contribute meaningfully?
Yeah, I mean, there definitely is a contribution. You know, I think that that's a little bit TBD as we're sort of locking things down. But definitely, that's a huge consideration to us is comfort, right? So we're definitely going to be saying this is going to be something you're going to be happy to have on your face for a long time.
Right.
So
Cool.
yeah. But I would say that one thing that you know, we worked on pretty extensively together is if you think about all the power that we're trying to put into this for the SoC, that power delivery network from the battery all the way through to you know, driving the displays and driving the SoC. You know, as you can imagine, with anything where you're trying to get a lot of performance out of it, you know, you look at a motherboard and it has all of these crazy capacitors and you know, all of the stuff that's really closely located. Putting it into a, you know, head-mounted form factor and having it be a battery, you know, powered device, a lot of challenges there. So this is the kind of stuff that Michael here, you know, definitely,
I would guess,
you know, had to look at transients and all of that kind of stuff, you know.
on some of the denser boards we've looked at, like the RTX Pro 6000 Blackwell board is a really good example of density of power components. And I know for them, unfortunately, I guess, in one way, the solution to solving the we don't have enough space problem was unfortunately spend more money on better parts, because that was the way to get the density they needed. You know, smaller inductors that do the same work, things like that. So.
Yeah, and we definitely have been. This is on the premium side of those types of components, especially. It's like this is, you know, the type of thing where we're saying, hey, we want to be able to run this thing flat out, you know, and we don't want any limitations in there. And ultimately, with it being a head-mounted device, there are going to be some thermal challenges, of course, but you know, that's been, you know, top of mind from the beginning, right? So,
how long have each of you been working on this?
So I worked on Index. You know, one of the reasons I work a lot more now on SteamOS type stuff, but I worked on the main board a lot on Index, and then immediately started working on this. So I've been working on this for 6 years, basically.
Wow. Okay.
Yeah.
And I'm just over 2 years.
Okay.
What? Hold on 1 second, you guys. I don't know what message I'm seeing right now. From Mira, so hey, noticed you just chatting stream solid content. I work with streamers to help boost their growth. No, thank you. Already starting out with, you're open to collaborating or want to grow your reach. Let's chat. Add me on Discord. No, thank you. I won't block you, but God, ignore stuff like that, man. Like, no, thank you. You haven't even. You said you notice. You're just chatting. Streams solid content. What? Okay. Like, nah. I just haven't even been streaming for that long, and I doubt you've been a subscriber or follower. So, whatever's.
Working on, so
Very cool. Yeah.
Yeah, but yeah, kind of typical thing at Valve. We're working on things for a long time, and when it's ready, then
It's ready when it's ready.
it's ready when it's ready.
Yep.
Yeah.
Yeah. Cool. Well, that'll be a good one for. We'll close that out here, I guess. So, I appreciate it. Thanks
Yeah.
for
All right. Thanks a lot.
walking
Yeah.
through.
Appreciate it.
Thank you. What's going on internally on this piece? Is it cable routing or?
So we call this the head strap. And so if you look at the center here, there's a connector. And so you can get power, and there's also a USB-C on the back, so you can get power and data into the core module, which you're holding. On the side here, we have integrated audio. And so if you see this bump out right here, this is where the audio is located. There are actually 2 drivers per side. And so the thing that's really interesting is when you integrate audio into a sensitive piece of equipment like the core module, where there's all sorts of tracking that's happening, the vibrations can be a limiting factor in terms of how loud the system can get. And so we've designed it with 2 speakers per side. They're actually oriented in different locations, in different orientations, so that they can cancel the vibrations at the IMU and the core while actually still doubling the amount of sound that the user is getting. And so there's also the battery in the back, which is sort of a head-shaped conforming multi-cell battery.
And then I guess an external cable going to the battery, is that right?
That's correct.
Okay.
And then with the Type-C port on back, if you want to extend it on your with a hip pack, or even play indefinitely plugged into the wall, users are free to do so.
Right, okay.
And this battery pack is 21.6 watt-hours.
There are inlets on the bottom. Those pull the air in. There's a centrally located fan on top, and then the warmer air comes out of the top. That's designed to keep your face cool, so you're not exposed to that thermal energy. I know, Joy, you actually did some visualization.
Yeah, actually, there's a clear version in the other room. And so that model we actually use to blow smoke into the system because there's many different inlets. There's a front side to the thermal cooling and also a back side as well. In the clear unit, you'll see a heat pipe that carries the heat from the SoC to the heat fin bake at the top. But actually, internally, there's a secondary heat pipe, and it's cooling from the back side of the PCB. So making sure that we can drive this to the absolute limit of how much power that you can pull from this chip.
So is the heat pipe, I guess, routed, is it just directly over the SoC?
Yeah,
Okay.
yeah.
On
So
both
there's
sides?
on the top side, there's a direct connection, but we actually pull heat from the back side as well through the PCB.
Right. I don't know a ton about, like I said, the sort of lower power parts, like ARM parts, but at least in a desktop, VRM also contributes a decent amount of heat, depending on what it is. So are the FETs any consideration in terms of cooling for this, or can you just push air across the MOSFETs?
There is an amazing number of thermistors in this. I think you can get the exact number from the hardware system engineer who's in the other room. That might be something like in the 40s. And so there's a number of things that we're interested in cooling in terms of.
That's mainly what I'm trying to get to as a career, be a computer hardware engineer. Anything with hardware, anything hands-on. So I am gonna have to learn more on the electronic side than the programming side for that kind of stuff. But I want to be able to do anything that pays the bills. If this stream content doesn't pop off, then I'm gonna need an actual career, right, or job. Anyways.
Also the cameras, but also the displays themselves get quite hot.
Okay.
So when you look on the clear unit, you're going to be able to see inside, but there's a front chamber and a back chamber, and we specifically have the air drawn into the back across the displays to cool them down.
Now, just a few things that I'm trying to get into, mainly computer hardware engineer, I said, right? Game development, I think, because I'm a gamer, fucking get into game dev. Cybersecurity, what was the other? Get into the drone industry and obviously hardware, electric, fucking engineering type stuff, and programming also goes into it. So cybersecurity, game development, anything in hardware, like specifically drone technology, that would be sick. That would be fun, I believe. And at least in the testing side. What else? What else? I think I had a fourth one, but I just can't think about it. Drone industry. Computer hardware. Would kind of be the same thing. Maybe that was my fourth one. I don't know. Cybersecurity. Game development. Oh yeah, artificial intelligence. But it's going to require a lot of machine learning, and machine learning requires a lot of math. And, yeah, it seems to be like everything seems time consuming, but that'll seem a little bit too difficult. I'm not, who knows? Maybe I'll get into artificial intelligence as well.
Okay.
And so there's a lot of analysis and a lot of ongoing processing, dynamic processing that's happening.
How sensitive is the display to thermal, or is it more of like getting heat off of the user?
No, the display behaves really well when it gets warm. It's actually a benefit. One of the things you want in VR is fast transition times because we run at such high frame rates. I haven't explicitly said it, but we work on the low end from 72 all the way up to 144 hertz. And the best way we're able to get those fast transition times at the higher frame rates is through the warmth of the device. So you can.
Now that is one thing. I believe the Quest 3 goes up to 120. Oh no, it goes to 90 hertz, right? I'm gonna have to look that up.
go too far, of course, right? Like a lot of heat. This is an LCD system. A lot of heat in an LCD isn't good, but there's this happy medium in between where the device is warmer than ambient and can therefore achieve really fast times.
What should I know on the acoustic side?
So for the audio side, we mentioned the built-in speakers, which are in the modules over here. There's also 2 microphones on the bottom. That's a broadside array to pick up a really high-quality voice. And then, of course, we designed the audio to be anti-vibration so that you can have a fully integrated system. The overall system is extremely light, so we also designed the audio system to be extremely light as well. And that is primarily...
Looking to get jacked, man, boy?
Nope. All right. Skip. Freaking Old Spice commercial.
So I only know a few audio buzzwords. I'll do my best to use all of them.
Sure.
Is there anything special about like the drivers or the diaphragm or anything like that?
Sure. So there's 2 16mm miniature drivers in each side. You can see here that they are pointed toward your ear. We have this metal grill with a secondary fabric mesh underneath that provides some dampening. And so we have these 2 drivers. They're located in an orientation about 150 degrees relative to each other, and they move in opposition. The sound travels here towards your ear. We've integrated the Steam Audio SDK. So for games that are non-VR, that you might normally experience on a speaker system or on a headphone system, we can apply our spatial processing for those games.
You had mentioned trying to account for vibration, I guess, generated elsewhere in the unit.
Sure.
So I guess are there any, as this is for the other guys too, but any challenges you ran into during engineering on the acoustic side or anything you were working on where was something that was actually kind of a monumental thing to clear?
Yeah, absolutely. So for this system, when you want to make sound, you want to have the largest speaker diaphragm possible, so you can move as much air as you possibly can. We call that volumetric displacement. So when you're trying to integrate into the system, this is challenging because you have a very curved surface. And so if you're trying to put a large singular diaphragm, it just doesn't fit. It's the square peg in the round hole, if you will. And so what we had done is we had separated that into 2 separate drivers. And then what that also allows us to do is make a lighter weight system, because the larger a system becomes, the more of a secondary suspension you need to have so it can support its own weight. And so by having 2 smaller drivers, we're able to have a much lighter system. And then in early prototypes, when we had these 2 drivers located on the side here, they were actually oriented in the same location. And so people wanted to turn the volume up, and they kept turning the volume up, and I kept adding more bass. And next thing you know, the entire screen was jumping and jittering in time in time to the music. And so we did a lot of
more.
We have a lab here with a lot.
More. Damn freaking Ben. Is it Ben? Yeah, Ben Solo's fucking more from the movie Star Wars. Yeah.
Accelerometers, a lot of lasers. There's an IMU on board, so we're able to pull all the information off of there and to really hone in on the types of frequencies and sort of dive into the tracking system to figure out what the issues were.
Right.
And then it ended up being relatively simple because we'd already designed the system to be form factor friendly and already have these 2 drivers we were able to swap one. It is a packaging challenge. It was very difficult to get it into the system, but it works extremely well. And we were measuring 18 times less vibration into the IMU, and so we don't have any of that visual jitter.
What's the metric for vibration? How is that actually quantified? Like, what's the actual unit of measurement?
It's interesting because there's displacement, but then there's also velocity, and there's also acceleration. And so if you remember from Physics 101, it's just derivatives of each other. So you can use any one of those metrics. But usually you would use acceleration is pretty easy to measure.
You mentioned lasers for measurement. My memory of that was the laser is basically used to detect these like micro movements in the inductors.
Yeah, so lasers are great because they're non-contact, and so you can capture the motion without interfering. And so sometimes when you have a microphone, you can pick up sound, and you pick up absolutely every single sound. And so your ear is really great because it's paired with a brain that just naturally goes through and say, that's this sound, that's this, that's this. But a microphone's pretty dumb. And so if you can shine a laser on something that's moving, and then you have an audio signal as well, you can do some coherence measurements between the 2, and you can just say, hey, this part of the sound is actually due to that particular pinpoint location on that device.
So are you kind of mapping like the spectrum, the frequency spectrum, to figure out which part of the spectrum is causing the vibration? Is that
absolutely
okay?
Yeah, it's interesting. When you have a speaker system, there's certain frequencies that move more than other frequencies, and in this particular device, it wasn't actually the frequencies that moved the most that were causing the most issues in the tracker. We had to really figure out how the energy was going from the location that the speakers are. You notice there's a separation between this gasket and the frontal core. So it's not necessarily like a direct path.
Right.
And then the IMU where it's mounted in the system has some amplification from its location. So and then you take all that back into the software layer and you see the sampling rate of the IMU. It was a little complicated.
Cool. It sounds like it blends the mechanical side too, right?
Oh, absolutely.
If you're trying to isolate, I guess, or because it seems to me like you would be through the whole process, you're trying to preserve the drivers you want to use and the stack, like acoustic hardware you want to use. And so I guess you probably try to deploy whatever mechanical solutions you can to isolate first, and then I guess you eventually run out of space to do things like that. So
yeah, and in this case, there's a lot of signal processing, like high pass filters, low pass filters, and there's the mechanical analogs of that in terms of what a high pass and low pass were. And we absolutely looked at that, and we're like, well, we need to get rid of these particular frequencies, so we're going to try to add something that's softer. But then that introduces issues because now your tracking system isn't rigidly mounted, and so you really need to, you need to consider the acoustic portion and the sound quality.
So my last live stream was an overview of like all 4 devices. It's Valve's Steam hardware, and Gamer Nexus's video on that. But yeah, towards the beginning of this little interview was mentioned on that on my live stream, but this one is going more in depth in the same interview when they're talking about the Steam frame.
And what you need to accomplish there. There's the mechanical mounting requirements for IMUs, and then there's a lot of software and a data analysis in terms of what's actually happening under the hood, because the frequencies that are causing issues on the audio are actually aliased in the system. So it gets really multi-domain. And we had a task force of people across the different parts of the system. We got together and said this is how we would solve it if we did it purely mechanically, if we did it purely in software, if we did it purely acoustically. And I think we ended up just solving it purely acoustically. It actually ended up being the most simple.
So does this sort of thing end up getting tested through like a HATS system or anything like that, where you're mounting the display to a test dummy for?
Yeah. So. Absolutely. It gets complicated, but yeah, so we have, obviously we're in charge of the display, so we can intercept the display directly. And so we were working on what would be an appropriate jitter metric. We were working with the computer vision guys on that. For the audio and for, we of course use head and torso systems to capture the sound quality. And so that we have certain targets. For the vibration itself, again, that was just a laser and accelerometers, and there was just sort of a specialty jig I set up downstairs that we just set that up to test.
So that covers it for now for the Steam Frame VR headset engineering discussion. We have a lot more from this trip, though. So we met with one of Valve's engineers who worked on the Steam Deck, and he has some really cool discussion about the deck versus the deck OLED, about PCB layout and engineering and design, things like that, challenges they ran into. It's not about a deck too, but it is super interesting information, really fun discussion. That'll go up separately, and we'll look around and see if we have any other interesting clips to put online too. But for now, that pretty much covers the Steam Frame VR solution, and we'll have plenty more to talk about with the Steam Machine and probably with the Steam Controller as we approach the actual launch in 2026. But in the meantime, make sure you check back for the Steam Deck conversation. Our policy is to pay for all of the travel and hotels ourselves for all these types of events, so if you'd like to support us in doing that to maintain our independence when we're doing reporting in the field, you can go to store.gamersnexus.net and grab our new Retro IO themed coaster packs, complete.
Yeah, go ahead and support them, guys. If you guys want to, store.gamersnexus.net.
With 5.25-inch drives depicted on one of them and a floppy disk in the slot, an old school controller with the original colorways, an IBM Model M inspired keyboard numpad,
and also subscribe to I subscribe to them. Like, yeah, I'm gonna learn a lot more being subscribed to someone like him who knows this shit than subscribe to others. So Gamer Nexus is one of the ones I'm subscribed to. Anyways, let's go back to his let's see his video. He said he had a video on the Steam Deck right here. We're gonna let's see, a RAM. This one's on the video saying you're fake news, gaslighting, GPU. Nope, we're gonna keep this.
Can't wait for you guys to try this. It is so.
Keep this in the subject of Valve Steam hardware. All right.
Hey everyone, so this is gonna be a pretty fun engineering discussion. So Yazan here.
Again, it's at 1.5 times. So if I don't know if you guys think that's a little bit too quick, too fast. It's easier to listen and understand higher speeds than the slow ass speed. I talk super slow, but I don't know. It's not like a normal conversation at 1.5 times, but I'm able to get all the intel in.
Worked on a lot of things.
Understand it.
The thing we're talking about is the Steam Deck OLED, which is not a new product, but when I covered that back when you guys launched it, I worked with you because you guys did some really interesting changes that when you look at the PCBs, stuff has moved and rotated, and it's not immediately apparent why. And so I think we can get some really interesting insight into some of your job on the engineering side.
Sure, yeah.
So where do we want to start with this?
Yeah, I mean, I guess I can maybe start with memory because that's actually usually what we start with when we do motherboard layouts. Memory has a lot of traces. There's a lot of stringent requirements on length matching and propagation delays and all that kind of stuff, and there's a lot of traces.
I have the Steam Deck OLED. Okay, it's the $650 one. So I got that one, the most expensive model. So yeah.
So it really kind of imposes all the restrictions, like how many layers you need is typically dictated by the memory you need. The location of the CPU and memory is typically done in like they're a group and they have to move together. There's not much ton of flexibility there. So typically start with memory.
Before that, this video is brought to you by Thermal Grizzly and their new Duronaut thermal paste.
Or by
PC builds and daily
memory ICs to being 2 by 64 memory ICs.
Oh, I remember that.
Yeah. So that was mostly because having two packages is just, they're smaller obviously, so that we can get more space. But because of the BGA density, it made the memory routing really hard.
Okay.
The fan out, right? Because the traces start with the CPU and they fan out to two memory ICs, so you gotta have more of a fan out to go with.
Right.
But with having two SPI 64s, you have to fan out and in fact fan back in to meet the memory IC.
Right.
So that actually was harder, but it opened up more space for us to kind of spread the components more, get better cooling.
Right.
But yeah, as I said before, the other thing we did was, because the CPU and the memory basically are a group, and you have to rotate them and move them in one block. We just rotated the whole thing, like I think 90 degrees.
I think it was 90.
Yeah, 90 degrees. And partly because, again, there's so many memory traces, that side of the processor is basically completely blocked for routing. It's all memory traces.
Right. You
So
can't run anything else.
so everything has to go around. Like even if you want to reach the Type-C port, which is directly behind the memory, you have to go down, go around, and because simply there's not enough space to go under memory. So
Well, and you mentioned this, but just in case anyone missed it, so my understanding has been memory traces need to basically be the same length,
Yes.
or at least have the same sort of delays built in.
So they have to. So the ultimate goal is to have the same. The ultimate goal is to have all the bits arrive at the same time, which typically means you need to have the same propagation delay, which is more or less that trace length has to be the same. But there's some details where if you have some traces on the top layers and some traces on the middle layers, the dielectric constant of air and the dielectric constant of the PCB dielectrics is different.
Okay.
So the speed of light is a little bit different, or the propagation delay is a bit different. So you have to actually keep that in mind.
So that actually, it's different enough that it actually comes into
Yes.
play?
Yes.
Okay,
Yes.
crazy.
So you have to not only that, but to meet impedance, like the top traces will have to be different thicknesses, a different width than the traces on the inside, or the spacing between the ground layer and the traces have to be different. So
Right.
you have to keep in mind the dielectric constant of what light is traveling
Whatever
through.
medium
Yes.
is on the other side. What about on the thermal side? So one of the things I think I remember the deck, the fan, if I remember correctly, is like central,
Yep,
right?
yep.
So the fan's roughly here. I want to say there's a plate here that has a slot under the plate that air can, I guess, get in through to the fan, and then this ends up exhaust.
Yes.
Is that all accurate?
So so basically we have we call it the mid frame. It's like a magnesium frame that is primarily used for rigidity, so like you can sort of yank on this thing and not bend it too much.
Right.
And basically the motherboard, everything mounts to it, uses a chassis for everything. And the way this is set up is that they have a blower here that sort of sucks in air from all kinds of places. Actually, there's a significant amount of air that comes to the triggers.
Oh, really?
Yeah,
Okay.
and the joysticks. We obviously have a ton of air coming through here as well, but there's a decent amount of air that comes from every little kind of gap that it can.
Is any of that, when you're doing thermal design, are you looking at like maybe we can pull air through the trigger, or is it just a byproduct of how the trigger was made?
It was not intentional. I
Okay.
mean, we knew it was going to happen, but
Yeah.
we're not trying to use it anyway. It was just
Got it.
based on the design. But it's important for us to keep it in mind while we design other things, because if you're not careful of how, like if we're trying to primarily channel air through here, if we're not careful, like we might not get a ton of air simply because it's coming through here and it's not
Right.
actually doing what you want it to do.
Right.
So we just need to know how the air is behaving internally. But anyway, so air's coming from all kinds of places. We have a battery here that is it takes up most of the thickness, so not a ton of air goes through here. But below and above the motherboard, we have air comes through. So the air sort of comes through here, travels over the RF shield, and we use the RF shield for heat sinking. So all the components on the top side of the motherboard that we think need extra cooling, we use a thermal pad or thermal putty to take it to the shield can. Like the SSD is an example of that. And so as air comes through, travels over the RF shielding, cools those. The components on the bottom side of the motherboard don't have that advantage. And so what we did is we created some gaps in the mid-frame.
So, see, someone's gonna have the same question out there. So I'm basically, well, not a question, more like a statement. So if you use this in a very humid area, or like for example, I was contemplating whether I should let's say I turn on the bath and I want to take a bath, so I have it turned on hot water, so it's all steaming up, right? If I close the door, the bathroom door and stuff, it gets all humid and stuff. It turns into a steam room and stuff. And meanwhile, I wait for the tub to cool down enough for me to actually go in. I was thinking of maybe I should play on the Steam Deck, wait for it to cool down just so that I'm not bored waiting for it or whatever. But that would be a no-no because the watertight integrity of the device is not that good. I was already thinking it wasn't because I'm like, it has a fan in it, so there's holes somewhere enough so that it intakes air and exhausts air. So that would be very bad if the humidity, basically the water, the steam gets in there, fucks with the components. Water and electricity, electric components do not mix. So it's not like a phone or a tablet, right? So I'm like, all right, use a phone, like a modern phone with watertight integrity, or somewhat waterproofed, like a tablet or an iPhone. So you could use that, obviously. Like being in the tub, so that I'm not totally just fucking just in there like falling asleep, and because that would be bad. Extremely hot water, end up being relaxed because of the heat of the water. Plus, I recently got into buying bath salts just to try and see if it works. I don't think it works. I think it just makes it smell differently. There's like a lavender one. It makes it smell good for about like 30 minutes or so, and then it starts dissipating stuff. The scent aromatherapy, I guess. I don't know. There's some other, not flavors, but scents. The bath salts have like magnesium and stuff. Apparently, magnesium can be somewhat absorbed in the skin, but I don't know. Whatever. I got into a whole tangent about that. Because I have insomnia, so I'm trying out as much shit as possible so I can actually go to sleep, or actually fall and stay asleep, because I also have sleep apnea. Jesus. But yeah, anyways, bad idea to bring that in a humid environment. So yeah, do not try to play your Steam Deck before or after you take a hot shower or bath. But you can still use it. Again, be sanitary when you do it. You could play on the toilet. Just be super sanitary. Don't cross-contaminate. And make sure you wipe your ass correctly. I use dude wipes, but you could use baby wipes. Baby wipes in the military was fucking awesome. Baby wipes, toilet paper to dry it off. Go back and forth until you have no more streaks. Anyways, that's enough of hygiene talk. Anyways, continue.
To sort of make air go up in certain spots, hit those components, and then get to the fan. And one of those, I think you mentioned, is like right here, that's directly underneath a memory regulator. Yeah. And literally just kind of put a small hole there for air to just kind of cool that component off.
Right. What about for moving the components around? So I think some stuff moved. I know a lot of it was because the memory module changed. Yep. But if I remember correctly, some of the VRM components moved also. Yes. So what was the reasoning for that? So
essentially, as I said before, by switching to the smaller memory ICs, it just opened up places so that we can put them where we actually wanted to put them, as opposed to where we had to put them, if that makes sense. Yeah. I think one of the things I mentioned is, when you make a product for the first time, you typically have some redundancy, right? Like, you're not like, oh yeah, we want to do I2S audio, but we want to have some other path just in case we want to try ourselves, or this component supports I2C and SPI, we're not sure which one to use, we're going to write both. But when you do a second-term product, you kind of figure that out, so you don't need as many of those kind of redundant paths as possible. So we removed those, which again opened up more space for us to move components to where we originally wanted them to, but couldn't because there was no space there. Yeah. So some of the CPU and the GPU VRMs moved from being directly underneath the APU to being on the side, closer to the fan where there's more airflow, where we would have loved to put them initially, but we just couldn't. Yeah. Similarly, some regulators also moved in a little bit more opportune places.
I don't know if I might be remembering this wrong, but I think something got a little shorter. It might have been the memory, but there was something that moved from like, it was a millimeter tall and then it became half a millimeter tall or something. Anyway, so I guess all relating back to being able to force air through different pathways on the board.
Yeah. And it's interesting, one of the things we noticed that by making again, we removed a bunch of components, and then we moved components around to be more optimal. We actually found out that some components no longer needed to be heat sunk to the RF shield can. And so we were able to remove some thermal pads and thermal putty.
Does that free up in any meaningful way, I guess, sort of the capacity, so to speak, of the shield can? I mean, if you're taking some power out of it, are you giving yourself any more headroom, or it doesn't really matter? Or?
It's so, there's actually, as a general rule, there's different strategies. One of the strategies is try to isolate the heat from the surface as much as possible, because the thermal limit for the CPU is 100 degrees. Right. The thermal limit for the skin is 48, 45, right? So if you're able to not trap the heat in the component and have the component be well within its thermal margin, that's actually the best thing you can do. But if you can't, then you can't. Yeah. And so ultimately speaking, what it comes to is there's only so much air that flows through the system, and as such, there's only so much thermal capacity that moves through the system. So the less components you need to cool, the better. Right. So if you can make that component just trap its own heat internally, that's really the best thing you can do. And so that's kind of what we ended up with certain things.
Very cool. Yeah. No, that's awesome. And then of course this will run after the Steam Machine coverage runs. But you were in the other video talking about this.
Yes.
So if anyone's curious about that, you can check that out. The only particularly different thing here is this is an e-ink display.
Yes, and just as I said, this is, again, not for sale. This is literally, we made it specifically for internal testing purposes. Yeah. This is just let's keep tabs on what the device is doing without needing a monitor plugged in, and it's just super useful for us.
Very cool. Yeah.
I'm sure somebody will make one.
Someone will make it.
But it won't be us.
Right. Yeah. Very cool.
Cool.
Thank you for joining me.
Yes, thank you.
And we'll see you all next time.
Yeah, thank you.
It's about to drop. No! Pause. Vitamin shop. The fuck? No, thank you. All right, so that was Gamer Nexus video on the Steam Deck. All right, we saw this one already, that he was talking about the Valve Steam Deck, desktop OS, Steam Frame VR, and controller. And then this one, more in depth on the Steam Frame itself, and I learned a little bit about my Steam Deck that I have. So there we go. That's enough of Gamer Nexus. Now let's go back and actually let's see how much time I've been streaming for. About an hour. Let's actually see if there's anything interesting. Let's type in Steam Linus Tech Tips. Jesus Christ. Microsoft reacts to new Steam machine. More Steam hardware news. Oh, hey, that's me, you guys. Hands-on Valve controller 2 in Steam machine. We haven't had one on the controller itself, so maybe we'll watch that one. So about the Steam machine price point. Unpacking Steam hardware, everything you need to know. By who? Nerdnest and 3 more. Multiple people who I do not know. New Valve announcement are insane. 2 days ago. The Steam hardware announcement was 7 days ago. Hands-on Valve Steam Frame virtual reality headset. Adam Savage, Gamer Ranks. I've seen this one. Steam new hardware, everything you need to know. Yeah, Asmongold. Let's. Oh wait, I actually watched Asmongold watching freaking LTT. So let's do that just to end it right there. Alright, Valve's new console. I think he watched this one. Valve's new console and controller Steam machine and Steam controller of 2026. So Linus Tech Tips video. But we're gonna do a little inception here. We're gonna watch dude watching another dude on YouTube, and I'm the dude watching them. Yeah, this one right here. He named it. Subscribe to Asmongold. That dude's funny. Did we get too excited? Did we get too excited too quickly? Question mark.
Valve dropped 3 absolute bombs today.
Nah, let's not do that. Should we? Nah. I want to give you guys the actual video from Linus Tech Tips. Cause he pauses and stuff every now and then. I want you guys to like see all 14 minutes and 31 seconds, but quicker.
The triple treat box is back, so you can holiday as hard.
That looks good, but no, thank you. Let's watch this video at 1.5 times.
Valve dropped 3 absolute bombs today. The Steam Frame standalone VR headset, that's gonna have to be a separate video. This one focusing on the new Steam machine, and yes, the wait is finally over, the 2026 edition Steam controller. Let's start with a little history. Over 10 years ago, Valve announced...
I have not purchased that one. I didn't know it was that old. The 2013 one. I got the next one at 2015. The Steam machine partnered with Alienware.
Their first version of SteamOS, a Linux-based operating system that would free gamers from the shackles of Microsoft Windows. No, it was a total commercial flop. But instead of giving up on Steam machines, Valve doubled down, working with game developers on Linux-native ports of their games and with open-source developers on the Proton compatibility layer that makes their Steam Deck handheld out-of-the-box compatible with thousands of Steam games, even ones that only ever shipped on Windows. The Steam Deck is believed to have sold millions of units at this point, and no wonder, given its great balance of solid gaming and outstanding affordability. But its mobile form factor has given it certain limitations and left gamers hungry for something more substantial. And well, here it is. I'm calling it the Lunchbox.
Gabe Cube. Gabe Cube is the official nickname of the Steam machine. Alright? But he's doing a segue right now. He does a lot of segues, which
and left gamers hungry for
entertaining,
something more substantial.
but
and well,
not like
here
Gamer
it is.
Nexus.
I'm calling it the Lunchbox. 1, because it's substantial, like lunch. 2, because it's cube-shaped, like a box. And 3, because I think this thing is going to eat Xbox's lunch. Okay, that last one was a bit of a reach. But not as far as I'm reaching for this segue to our sponsor.
Hold up, Roblab is having a sale, 60% sound.
It's,
You can win a ROG
it's funny. Watch it, you guys itself, but I'm not gonna watch it again. It's cringy. It's funny, entertaining, cringy, but nah, no thank you.
In what has become typical Valve fashion, they've been atypically open about the new Steam Machine, giving us direct access to the engineering folks who worked on these devices. The only thing I didn't have today was time, so we're going to get through this as fast as we can. At the heart of the Steam Machine is a 6-core AMD Zen 4-based CPU that turbos up to 4.8 gigahertz with...
Alright, so AMD 6 cores Zen 4, semi-custom AMD RDNA, 8 gigs of GDDR6, 16 gigs of... I need to upgrade my Steam, is not the Steam Machine, but the Steam Deck memory. I think it's at 16 gigabytes of RAM right now. Should probably upgrade it. Let's see. It does all right. 512 gigabytes or 2 terabytes micro SD slot. Okay.
16 gigs of RAM and an 8 gig GPU that they compared to a 7600 XT-ish. But they were also quick to point out that it might not be apples to apples thanks to their custom software stack and power tuning. Basically, the goal was that pretty much anything on Steam should run at 4K 60 FPS if you're willing to turn down the details and use a little bit of FSR upscaling. And we saw that on display with Cyberpunk running in the demo room at these settings. Valve says to expect about 6 times the performance of the Steam Deck. Now, I was a little surprised to not see an SoC with shared memory, but apparently the decision to go for discrete CPU and GPU came down to balancing cost, power, size, and performance, and also they just didn't feel like they needed to. And I guess Valve was right, because they nailed this thing. Compared to a more traditional ITX small form factor machine, like the OG Steam Machine reference design, you can see that it's a lot smaller. More on par with a highly integrated design like something like the Framework Desktop. Investment disclosure. Like the Framework Desktop, Valve allows customization of the front panel using these magnetic plates, and they're going to provide the CAD files so you can put whatever your heart desires on here. They even had a machine in the demo room with an e-ink display that was showing system vitals. Pretty darn cool. But unlike the Framework, it has a programmable RGB strip in the front that could be used to personalize your style or maybe show a progress bar while you switch your TV input and wait for your game to be downloaded. The sky's kind of the limit. The front of the device has a power button, micro SD slot, 2 USB 3 5 gigabit per second ports. Then the rest of the I/O is in the back, where you'll find 2 USB 2 Type A ports, a USB-C 10.
All right. Look at all the ports, you guys. So the PSU, the power supply unit, is inside, and all you do is plug in the little cable. So, yeah. Now it is a cube, so if it's not like the PlayStation 2, PlayStation 3, the Xbox like 360, if you put it sideways, you can make it fit in narrow spots and stuff. This cannot do that because it's a cube, but you can find a place for it. It's not that big.
Gigabit per second port, no display port on there, that is worth noting. Gigabit Ethernet, power in for the integrated power supply.
Wait a minute. You said no display port? I see one right here. Display port 1.4 right here. And I think, oh, because like watching Asmongold's video, like I was wondering why he paused it there. This is why he paused it, because he was like pointing at this too. Oh, okay. I was kind of like I was playing in the background while I was eating.
10 gigabit per second port, no display port on there, that is worth noting. Gigabit Ethernet, power in for the integrated power supply. Good gravy, this thing is compact. As well as an HDMI 2.0 and DisplayPort 1.4 port. It is worth noting that HDMI 2.0 port, they have tested it at HDMI 2.1 speeds, but there are a couple of features that are not implemented, so they can't call it HDMI 2.1. Also at the back, we have a large 120mm cooling fan that draws air from both the intake on the bottom, that comes up through the power supply, as well as the large heatsink on the front. We're going to crack this thing fully open in a sec, but first, I want to talk about the Steam controller. No, not that Steam controller, the new one, with the exact same name. Before you ask, yes, I made my case to Valve that this is unnecessarily confusing. No, they're not going to change it. The good news is Valve learned a lot.
Not that confusing. It's pretty fucking old, so like they're not gonna go. This is gonna be the actual Steam controller. Like they only have to make one, and then I don't know. It's not like the Xbox where it has like the Xbox Elite. If they do make a better or different version, then they'll give it a different name. The Steam controller. This is gonna be like the Valve Steam controller. It's not confusing, Linus. It's not.
First Steam controller, and this appears to be their most complete offering ever. To be fair, the original was really cool. I mean, it made non-controller games.
Yeah, I do kind of miss it. Like that, the one analog stick was at first like using it was a little bit confusing. Like how, but I got used to that big old circular pad on the right, using it as an analog stick is actually pretty accurate. Like it follows your your fingertips pretty damn good, and you can play PC games and stuff. There's like different. There even back then were like different Steam layouts and stuff to be able to play that Steam control, like use the Steam controller to play the game with it. There was layouts plus community-driven layouts that you could test out, and it was actually pretty cool. Each game had one. Someone out there will tinker with the settings and shit and create it for you guys. So, yeah, Steam community is awesome.
Games finally playable from the couch thanks to their innovative haptic touchpad. They also unlocked novel input schemes with gesture control or like swiping with momentum. But they also turned off a lot of folks due to their deficiency of traditional joysticks. Well, that's solved now. The Steam controller is everything that is great about the controller on the Steam Deck.
What more do you want?
Usable when you're...
If you guys can see right here, if you guys visualize the PlayStation remote and the Xbox remote, fuse them together, all right? Like this is the 8BitDo controller, which is more like the PlayStation remote right here. So like this kind of, it's not exactly the same, I know, I get it, but like it's kind of like this layout right here, and the Xbox remote is different, right? Now imagine fusing both of them. That's what the Steam controller looks like. It actually looks like the 8BitDo remote with the damn what's called, not the case, damn stand, the charging stand. Hopefully you guys can see that. Trying to bring it out as much as I can. So right here, this remote came with the charging stand, little LED in the bottom. Anyways, that's how the Steam Deck looks like right now. It's bulky, except like this little part right here is cut off, but it's thicker right here on this part right here. Anyways, that's what it reminds me of right now. I don't know, some people have small hands, women, so this remote might not be for them. But the good thing is there's a bunch of remotes you guys can get on Amazon for the same price as a PlayStation remote or Xbox remote. So
your Steam Deck is in dock mode, or with your Steam machine, or with any other PC investment disclosure. On the surface, it offers up a conventional ABXY button layout with a PlayStation-style symmetric joystick design that will work seamlessly out of the box with basically any game. The trackpads have been repositioned to better accommodate the arm's natural position while holding a smaller device compared to the wider Steam Deck, and all of the usual Valve buttons are included. A Steam button for opening the menu, their quick access button for bringing up the SteamOS overlay, 4 rear programmable buttons. The face buttons are satisfying with a nice amount of resistance, and the D-pad has been tuned from the Steam Deck for a better feel. It feels okay to me, but I only got a couple minutes with it before Valve blew my mind. The joysticks are next-generation TMR or tunneling magneto-resistant joysticks.
Now this part, because I searched up TMR in my first damn freaking live stream, ChatGPT did not give me this definition. So tunneling magneto resistance, whatever.
Boasting superior accuracy and durability even compared to Hall effect joysticks. And the controller has been designed from the ground up for a superior gyroscopic aiming or mousing experience with capacitive thumbsticks and even capacitive grips, so you can configure your gyro to enable or disable depending on whether you put your thumb on the...
See, Xbox remote does not have that. Like their base remote doesn't have that. The 8BitDo does, and the other 2 remotes. I have a video out there on like 3 remotes that I bought for the Steam Deck. It works for the PCs as well, or anything you could connect the Bluetooth to. So yeah, you go ahead and check out that video. I'll show you guys how to even get there. On my, let's see, my channel over here, you go over here and you go to videos. All right, and then you can, yeah, I've been playing Need for Speed Most Wanted a lot on my Steam Deck and just uploading it. Been getting copyrighted because I actually kept the music in, but whatever, I don't care. I'm not monetized yet anyways, because I'm not even at 1,000 subscribers and not enough people view my content. I'm gonna get back to playing The Witcher 3. I played Godzilla, the PlayStation 3 version, on my Steam Deck through emulating. But here's my video right here. It's called Best Controller for the Steam Deck ? FlyDigi Vader 4 Pro. That one so far is my favorite. The Easy SMX X20. my second favorite. Sometimes it like not lags, but like it disconnects or connects like quickly, but it creates issues. I don't know. I think it connects, disconnects, and it does it repeatedly, and it messes with the connection. Like because it's connected to the hub. The hub's connected to the PC and my TV via HDMI. So there's like a little lag right there. Sometimes I have to disconnect the USB Type-C that's connected to my Steam Deck itself, connect it, disconnect and connect it again, wait for it to fix itself on the TV screen, and then I could continue playing it. But whenever I use the Vader 4 Pro, it doesn't do that as much. Well, at all, I think so. I haven't been using this one, the Ibido one, so far, but it's pretty cool because it has LED. I'll show you guys real quick. Let me turn this bitch on. Will it turn on right now? There we go. LEDs on the analog sticks, and LED right here. It has some buttons in the back, some paddles, like 2 of them in the back too, and it has trigger locks right here, and it has an extra button right here, right next to the triggers. There's one in the middle. Anyways, whatever. You guys go ahead and check out that video. This remote, because I'm gonna eventually get back to streaming video games on the PC, except when I find the time. If not, it's gonna be on the Steam Deck, and I'm just gonna upload the gameplay without any commentary and not streaming. That's gonna be mainly on my YouTube, probably not even Rumble. But whenever I stream on all 4 channels: Kick, Twitch, YouTube, and Rumble. So whenever I'm live streaming content, you'll find it on all 4, and if not, it'll be on my my YouTube. Under the playlists over here, you can see Need for Speed itself. I have 8 videos. Basically, each video is like an hour, maybe less. So 8 hours of that. I'm gonna put all my podcasts and reactions right here. So like this one is gonna be on this playlist. Call of Duty Finest Hour is actually pretty difficult to play on a remote. I'm stuck. I'm stuck on this one. Anyways, I'll get back to playing The Legend of Zelda: Ocarina of Time. Yeah, there's just a bunch of games you guys could play if you emulate. I'm probably gonna start emulating games on my PC, but anything that's like shit. Alright, let's get back to the video. I think I lost my spot.
The Colonel was obsessed with making the...
Anyways, some games on the Steam Deck itself... crap. Need to find my spot where I left off. I think it was right here. Yep. Anyways, what was I saying? Emulating on my PC, I'm gonna do that on my live stream. Me having that connected. Dolphin emulator is already installed, I believe. That one. Let's see, games, Dolphin, somewhere right here, right? Whatever, Dolphin emulator you'll be able to find on Linux right here, the Discover Store. Let's see, I go right here and put Dolphin, Phin, enter. So Dolphin emulator, I guess I don't have it. It's for GameCube, Wii, Triforce emulator, whatever. There's some other emulators that you could download straight up on the Discover app. If you're using Arch Linux KDE Plasma, then you'll be able to find it. If not, just Google it, and then, or you guys will be able to get it on GitHub, and or just use ChatGPT to help you do everything and then install and emulate these games. Do not get the EmuDeck on a PC, just straight up get those emulators on your PC, whether it's Windows, Mac, or Linux. Get those directly because your PC is a lot more powerful, a lot better than the Steam Deck itself. The EMU Deck is mainly for the EMU Deck to make it more possible on its hardware and stuff. It's apparently going to get better in the future, and hopefully it does. But there's certain games I tried playing the 360 version because of Need for Speed Most Wanted. Graphics was good, but it starts to freeze. It's not the Steam hardware, it's the Zemu, whatever. The emulator that you use in order to play the Xbox 360 ROMs on the emulator itself, on whatever, it causes issues with the Steam Deck, and it ends up not being like playable at all. So I'm just playing the Xbox version of it, and it's playable and it's fun. F it, I'll probably play that game later on in the future on the PC, just because the graphics and the capability of my PC. I'll probably be able to play in 1440p or 4K, and then yeah, there's other YouTubers that are already doing that, so you can watch their gameplays of Need for Speed Most Wanted, one of the best and best nostalgic racing games growing up. Anyways, back to the Steam controller. Oh, you're muted.
Of traditional joysticks? Well, that's solved now. The Steam controller is everything that is great about the controller on the Steam Deck, but usable when your Steam Deck is in docked mode, or with your Steam machine, or with any other PC, investment disclosure. On the surface, it offers up a conventional ABXY button layout with a PlayStation-style symmetric joystick design that will work seamlessly out of the box with basically any game. The trackpads have been repositioned to better accommodate the arm's natural position while holding a smaller device compared to the wider Steam Deck, and all of the usual Valve buttons are included. A Steam button for opening the menu, their quick access button for bringing up the SteamOS overlay, 4 rear...
What's up, Sarah Harris SH1? Hey, how's your day going so far? It's going pretty good. It's what? It's like 8:15 p.m. It's going pretty
programmable
well.
buttons. The face buttons are satisfying with a nice amount of resistance, and the D-pad has been tuned from the Steam Deck for better feel. It feels okay to me, but I only got a couple minutes with it before Valve blew my mind. The joysticks are next-generation TMR or tunneling magnetoresistant joysticks, boasting superior accuracy and durability even compared to Hall effect joysticks. And the controller has been designed from the ground up for a superior gyroscopic aiming or
Thank you. You're welcome, and thank you again.
mousing experience with capacitive thumbsticks and even capacitive grips, so you can configure your gyro.
Remember to follow or subscribe
to enable or disable, depending on whether you put your thumb on the stick or even by simply loosening your grip, say to recenter and then reactivate gyroscopic aiming. They had a great demo with Balatro showing how you can use the game's built-in controller compatibility like a pleb, or, hear me out, trackpads with the right for movement and the left one split down the middle.
Why the hell would you use Balatro as a whatever? You could have used any other game. Why Balatro?
For left and right click. Or, hear me out again, gyro mouse using the face buttons for clicks. And if you don't care about gyro aiming, these capacitive inputs are all remappable as well, opening up a whole world of possibilities. Let's go even deeper. In addition to the haptic, texture-like feedback that you know and love from Valve's previous touchpads, the Steam controller has been upgraded with large rumble motors for better immersion and a large battery that they claim should be good for 35 hours in the most demanding applications, and even better if you don't need quite as much rumble. But I haven't even talked about the best part. If you've ever gamed over Bluetooth, you know that it can be inconsistent at best. Valve's solution? The puck. Every Steam controller comes with a wireless dongle that clips magnetically to the Steam controller using a couple of nice, strong alignment magnets, and it uses a proprietary 2.4 gigahertz wireless interface that Valve claims is good for about 8 milliseconds end-to-end latency and offers up superior resiliency when you're using multiple controllers. It allows 4 controllers per puck, so that's not as good as the Xbox dongle, which can do 8.
4 is plenty. Like who? Like 4? Oh, okay. Now, with the implementation of being able to connect 4 remotes, they need to make more multiplayer like what's it called? Jesus. Like in-house, I don't know, like when you have visitors over, you guys could play the same game on the couch. When you connect those remotes, they need to make those kind of games possible again. Not everything needs to be online, okay?
But Valve has tested up to 4 pucks on a single system for a maximum of 16 players, meaning that you're probably going to run out of seats on your couch before you run out of controller compatibility. The last chef kiss on top is an IR emitter that's cozied up beside the power LED to help you find your controller when you're in VR. I love it. Now let's get back to the Steam Machine, who got naked while we were busy. Oh, you. While Valve's goal was to build something that is zero hassle, grab and game for the non-tinkerers, they really were laser focused on a console-like experience with quick suspend and resume and modern standby so that your games are already updated when you sit down to play. They also fully acknowledge that there are folks out there, guilty, who are tinkerers, and they've come up with an ingenious design for this thing that allows it to cater to both audiences. In advance, no, you're not going to be swapping out the BGA soldered processors. But what you can do is upgrade the storage with next to no hassle to a 2230 or larger 2280 sized M.2 drive. And while we couldn't go that deep today, Valve also confirms that the memory uses standard SODIMM slots. Finally, while Valve hasn't actually told iFixit that this product is coming yet, they did say that they're in here, by the way. There are some really cool details that I'd love to highlight. The power supply, for one thing, is fully integrated to the point where it's actually part of the chassis, and the cooling solution pulls air directly through it, which avoids any need for it to have its own fan. The aforementioned Delta cooling fan is actually slightly thicker than the standard 25mm for extra static pressure, and it includes antenna mounts that are integrated into it, along with...
Do I live daily, says Sarah? No. I do it whenever I can find the time. I'm a college student right now, trying to be a computer hardware engineer. I'm at Sac State University. Anyways, only because we're getting close to Thanksgiving and Christmas, and semester is almost over, so I'm starting to have more time. Although, gotta make time to study for exams. Fuck my life. Anyways, yeah, let's get back to this.
With I/O mounts. Cool, right? Oh, this is actually a great look at the 4 antennas. So this is the back of the device where you have your 2 antennas for Wi-Fi 6E. Then if we flip it around to the front, we've got 1 antenna for Bluetooth peripherals and another one that is dedicated to your Steam controller or controllers. So that puck that's included with your controller is actually extra, and you could chuck it on another PC or next to your couch for charging. A major question mark, though, is of course price. Valve wasn't able to give any specific numbers due to rapidly evolving market conditions, but they will obviously have it nailed down when the Steam Machine launches in Q1 2026 alongside the new Steam controller. They did give me one hint, though. They said that while they expect it to be very competitively priced with a PC, that it will be priced like a PC.
Do I play games? Do you breathe air? That is saying yes, I do play games. You'll find a bunch of my games on my YouTube channel. Oh crap, I did it again. Oops, I lost my spot again on this video. Anyways, yeah, you can find me playing a bunch of games whenever I'm not live streaming. Everything's on my YouTube channel via playlists. And yes, I did lose my spot again. F me. F me. It's my mistake. It's not your fault, Sarah. It's mine. I think I was right there. Which game do you love the most? That is a loaded question, Sarah. You're messing with me. I can't think of one. I'll just go with I'm currently playing The Witcher 3, Need for Speed Most Wanted, the Xbox original version via my Steam Deck, emulated on my Steam Deck. And some other games. Some of my favorite games. The Legend of Zelda: Ocarina of Time is one of my most favorite games. That I love playing over and over. So I'm actually able to play that again. Let's see. I'll show you my library. Like, it's going off topic from my damn what's it called? Crap. Let's see if I can show you guys. Let me load it up real quick. Updating Steam. I'll show you my Steam library. Yeah, it's updating. I haven't been on my PC to play in a while. Excuse me, sorry. Jesus. Soda does that. It's taking too long. New tab. Steam. Let's go to my Steam. You can find me. I gotta log in again. Anyways, just trust me. I play a lot of video games whenever I can, if I have time.
thing that allows it to cater to both.
I'm an
audiences. In
alright
advance,
streamer.
No.
Like, have you seen the amount of followers I have on Twitch? And no, not all of them are watching my shit
You're not
right
gonna be
now.
swapping out the BGA
Probably
soldered
bots.
processors. But what you can do is upgrade the storage with next to no hassle to a 2230 or larger 2280 sized M.2 drive. And while we couldn't go that deep today, Valve also confirms that the memory uses standard SODIMM slots. Finally, while Valve hasn't actually told iFixit that the users, awesome. Since we're in here, by the way, there are some really cool details that I'd love to highlight. The power supply, for one thing, is fully integrated to the point where it's actually part of the chassis, and the cooling solution pulls air directly through it, which avoids any need for it to have its own fan. The aforementioned Delta cooling fan is actually slightly thicker than the standard 25mm for extra static pressure, and
Sure, since you're my only viewer right now, then yeah. Where am I from? Cali, Sacramento. Ew.
actually a great look at the 4 antennas. So this is the back of the device where you have your 2 antennas for Wi-Fi 6E. Then if we flip it around to the front, we've got 1 antenna for Bluetooth peripherals and another one that is dedicated to your Steam controller or controllers. So that puck that's included with your controller is actually extra, and you could chuck it on another PC or next to your couch for charging. A major question mark, though, is of course price. Valve wasn't able to give any specific numbers due to rapidly evolving market conditions, but they will obviously have it nailed down when the Steam Machine launches in Q1 2026 alongside the new Steam controller. They did give me one hint, though. They said that while they expect it to be very competitively priced with a PC, that it will be priced like a PC, rather than like a console with games subsidizing the upfront.
PlayStation 5 Pro says $750. Xbox Series X 1 terabyte version is $650, which is as much as I paid for my Steam Deck OLED. Damn. Yeah, if they sell this shit for like $1,000 or less, they'll be able to sell it. Again, my PC that I made myself was $1,500, and I could play everything in 1440p, and some games I could put ultra settings, 4K. Well, most of my shit I could put in high and ultra settings at 1440p. Some games, if you want better frame rates per second, then put it down lower.
Hardware purchase. They wouldn't say why, but if I had to guess, I'd say it's partially to avoid
Give me a suggestion.
Potential partners for
Sure.
Steam games and Steam software, but also because they recognize that the Steam Machine is a full-fledged PC, capable of being used as a full-fledged PC. There's no guarantee then that, say, a corporate purchase of 10,000 of these things would result in a single game sale. So they really do need to protect the sustainability of their hardware business. Another major question mark is, where the heck is standalone SteamOS for custom PC builders? Well, we aren't going to get a formal SteamOS release for BYO hardware configurations anytime soon, but Valve has expanded the list of supported third-party devices, and they have supported installing the Steam Deck recovery image on AMD CPU and GPU systems for some time, and recently updated it to support their latest Zen 5 and RDNA 4 architecture processors. So nothing prevents you from building your own Steam Machine and installing the software for free, though you will miss out on some things. HDMI CEC control, for instance, required Valve to build a custom motherboard in order to have your computer turn on alongside your AV receiver. And to get that on a BYO PC would require some serious cooperation between hardware makers that I don't know if we should hold our breath for. But the bulk of the experience should work pretty much out of the box. We may even get a release that supports a broader range of hardware in the future. But the vibe I'm picking up on around here is that it really depends on better support for Intel and especially NVIDIA GPUs. I'm also picking up this vibe to our sponsor.
No, thank you.
Go check out the video on the Steam.
Alright, that's enough Intel and watching stuff on YouTube for the Steam. I'm about to end the stream, so let's see. Let's see. You think adding some cool and eye-catching content to my channel could help bring in more views? Stuff like a nice logo, banners, animations make big difference. You design things like that, so if you like, I can show you what I've made. No thank you. Respectfully, I don't. No thank you. You don't have to follow my stream, and good luck at making money. Keep that hustle. I am not gonna be one of those, unfortunately, so that is gonna be it for my stream. And alright, thanks for watching, you guys. Have a good one. Alright, until next time.